Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shang, coming to you live from Alameda International High School. In this video, what we're going to be working on is we're going to be multiplying and dividing some rational expressions. And so what we're going to do first is do a little bit of review. So again, anytime you think of something that's rational, you're thinking of a fraction. So what we can do is do a little bit of quick math. So if we are simplifying these fractions, we're going to be multiplying them together. So if I have 16 over 5 and 15 over 8, and we're going to multiply those together. And make sure you're saying if that dot is in the middle, it means multiply. If there's, the multiplication symbol or parentheses, again, different forms for the same idea for multiplication. Make sure you're thinking though that fraction bar in the middle is saying divide. So what we can do is we can kind of work on the diagonals, and we can still just say, hey, what's 15 divided by 5? Well, I can simplify that. I can divide both of those by 5, and so I have 1 and 3. Same idea with 16 and 8. I can say divide both those by 8, where this is 1 and this is 2. What you can do now, multiply your numerators together. So I have 2 times 3 is 6, and 1 times 1 is 1. Again, you can also just write it as a whole number. So you'd say 6 over 1 is just 6. So again, make sure you're simplifying, look for that common factor, and be able to divide. Similar idea with the second one. I have 49 and 7. Common factor is 7, so this is going to be 1 and 7. And then for 9 and 81, divide both those by 9, and so this is going to be 1 and 9. Then I just have 7 times 9 is going to be 63. Anytime you have those dividing fractions, make sure you multiply. So divide fraction is the same as multiply by the reciprocal. What that means is I'm very careful on it, but what you mean is this: you can flip that second fraction and multiply it. We're talking about the multiplicative inverse, and so we're saying, okay, if I was to rewrite this, I would have times, and I'd have 28 over 21. That way we can, simplify it just like we've been doing. So we have 3 and 21 are both divisible by 3. So I can say this is 1, this is 7. And then we can say that both of 7 and 28 are divisible by 7. So I can say this is going to be 1 and 4. Multiply my numerators, and so I have 1 times 4 is 4, and 1 times 7 is 7. So again, make sure you're multiplying by the reciprocal when you are dividing fractions. So same idea, I can multiply by the reciprocal. So I have 3 over 2 now. And so I can cancel these out. So I can say this is going to be 7, and this is going to be 1. And I can say this is 1, and this is 2. Now I can say this is going to be 7 times 1 is 7, and 2 times 1 is 2. So again, make sure you can simplify those fractions carefully. All right, so that's a quick review on those multiplying and dividing fractions. Now what we're going to do is we're going to have similar idea with our rational expressions. And since we're talking about expression, we're saying, hey, it has that variable in it. Make sure you're saying if there's any kind of restrictions, we're saying we cannot have 0 in denominator. All right, so let's kind of remind ourselves how this works. So similar idea, I'm going to say, hey, I can simplify my integers like we've been doing, but I want to make sure I'm thinking, there we go. I want to make sure I'm thinking, okay, look at my variables. So I can say, well, I can use the exponent rules for division. So I can subtract the exponents, the power, there we go. So I can say I have x to the third power minus x to the first power. So I'm going to say that's going to be like this. So I know I have same values from above, so I know I'm going to have 6 in the numerator. And then I can say, what else do I have? Well, I have 3 minus 1 is 2, so I have x squared in the numerator. And I can say, all right, what about y? I have y to the second power and y to the first power in the denominator, so that's just going to be y to the first power in the numerator. And then in our denominator, what are we going to have? Well, we have z to the third power in the denominator, and we have z to the first power in the numerator. So that means what's going to be left over? Well, we have z squared in the very bottom, and make sure that you can have your restrictions, so we can say z cannot be equal to 0. So you can make sure you have that as part of your answer. Again, we're just simplifying these expressions by kind of writing, it's almost like we're extending this fraction bar out. So that way we have one long expression, but we can simplify it so that way it's not as messy. Similar idea for the example number 2, however, make sure you can factor first. So be sure to factor. Again, make sure you can check those other videos if you forget how to do that, but I'm gonna work through it like so. So I'm gonna say it like this. I'm gonna break it apart, and so I can say, all right, for my top left one, I have the product is 12 and the sum is 8. So I need two numbers that multiply together to get 12, whose sum is 8. So I'd have it like this. I'd say x, and then again, there's same sign since the product is positive, and they're both going to be positive since the sum is positive. So again, make sure you can build your foundation, have your sum and your product. So I know, again, these two added together is 8, these two multiplied together is 12. So I'm going to have it like that, and then we could say, all right, let's have our top right one. Product is -24, sum is -2. So I'm going to say, let's have 6 and 4. So I can do it like this. I can have x and x. Again, make sure you're looking at that product to have your signs. So I know I have different signs, and I know that the larger value has to go with a negative, so I'm going to have 6 and 4. Bottom left, difference of squares, so that's to be the same number. Real simple. And bottom right is going to be, let me draw it like that. And bottom right, let's see, same sign because the product is positive, but they're both going to be negative. And so we can say this is going to be 4 and 2. All right. So once you have your factors, like so, you can have your cancellations that you want to do. So I want to reduce this or simplify it by canceling out those common packages. So kind of look for the same amounts, similar factors. So I can say, hey, right away I have an x minus 6 on the top and the bottom, meaning I can simplify and cancel out in the numerator and the denominator. Be careful, again, take one quantity or package at a time. That way you can say, hey, I can eliminate some of these values. So what else do I have? Well, I have an x plus 4 in the top and the bottom. That cancels out. And that's going to be it because, again, I have x plus 2, x plus 4, and x minus 2, x minus 4. So I'm going to say this. My answer is going to be that those two packages in the numerator, so x plus 2, x plus 4. Again, multiplication, use your parentheses. Same idea for the denominator. I have x minus 4 and make sure I have multiplied together and x minus 2. Make sure you write your restriction. So I'm going to say, let me make sure it's in there. I'm going to say my values for x. So x cannot be equal to, well, I have to have two of those values that can't be. It can't be positive 4 and it can't be positive 2. Again, that would make our denominator 0, so it has to be both of those restrictions. Similar idea on the back. We're going to say we have our fractions first. So again, make sure you can rewrite your expression, multiply by the reciprocal. So I'm going to have my first rational expression stays the same. So I have x squared minus 9 all over x squared minus 8x plus 16. what I can do is I'm multiplying by the reciprocal. So that means, again, have your denominator in the numerator now. So I have x squared minus 7x plus 12, and have the numerator in the bottom now. So I'm going to say x squared plus 6x plus 9. And make sure you can flip your fraction, multiply by the reciprocal. Now we can factor it out. So again, when you divide, it's just like multiplying by reciprocal. Okay, so now what we can do is factor it out. So I'm going to have two sets of fractions, and I can say, all right, be able to build my fractions like before. Difference of squares, meaning it's the same number. So I have x plus 3, x minus 3. And then I can say I have, in my denominator, I'm going to have x and x. So let's see what we have. We have a product of 16. Same sign since it's positive. However, both of them are going to be negative since our sum is negative. And I can have, let's have 2 and, nope, just kidding. Let's have 4 and 4. There we go. That's a little bit better. Can always double check. Multiply together, get positive 16. Add together to get negative 8. So that checks out. Working in the second rational expression, I work on the numerator first. So I have, again, build your foundation, 2 sets of parentheses, 2 packages. I have same sign since our product is positive, and they're both negative since their sum is negative. And I could say I have 3 and 4. Working the denominator, same sign because they're positive. And our sum is positive, so I can say I have 3 and 3. All right, now that you have this factored out, you want to make sure that you're canceling out from the numerator and the denominator. Again, that's what that fraction bar means, is just divide. So we want to make sure dividing or simplifying are common factors. So I can say, all right, I have x minus 4, top and bottom. I have x plus 3, top and bottom. And that seems about it. Again, make sure you're just taking one package from the top, one package to the bottom that are the same, cancel them out. Everything else has to be left alone. So I'm going to have x minus 3 times x minus 3 in the numerator. In the denominator, I have x minus 4 and x plus 3. Make sure you write your restrictions on that x value. So I'm going to say it can't be equal to positive 4 and negative 3. Again, if you're ever confused on how I get those values for x, again, make sure you're saying, okay, you're essentially solving the equation x minus 4 equals 0. We're trying to make sure what value would make this true for both of these equations. And since x can't be these values, we'd have to put that in for our answer as well. And then last one, making sure it's on, there we go. Making sure it's on there. So we have, again, multiply by the reciprocal. And so what I can do is this. I can say, hey, I have, instead of now, I have times, and I'm going to say I have x squared plus 3x minus 28 all over x squared minus 8x plus 16. So again, make sure you're multiplying by that reciprocal when you divide those fractions. So now what I can do is this, I can rewrite it when I factor. So I have like so, 2 sets of parentheses for these quadratics. So I'm going to have x plus 4, x minus 4. In my denominator, what I can do is I can factor out a 2. So I'm going to say I have 2 times the quantity x plus 4. Work in my numerator top right, I have x squared plus 3x minus 28, different signs since my product is negative. So I can have x plus and x minus. Look for the larger value being positive. So I can have, let's have 7 and 4, since my sum is 3 and my product is 28. two sets of parentheses, x in both of them. And let's have same sign since the product is positive and their sum is negative, so that means that both of them are going to be negative. And I can say, what do we have before? Same as that last problem, I can have -4 and -4. Now that I have all these factored out, and I'm undoing that foiling. Make sure you're thinking, again, anytime you factor, you're undoing that foiling step. So now what I can do is I can simplify these rational expressions by canceling out these packages. So I have an x plus 4 on the top, x plus 4 on the bottom. I have an x minus 4 on the top, x minus 4 on the bottom. I have an x minus 4 on top, x minus 4 on bottom. Whatever's left over is what I write for my answer. So I'm going to have my answer be x plus 7 all over 2. I don't have to have a restriction on this one since my denominator is just 2, and so I can just have my values for x. Again, be sure to ask any questions as they arise, and as always, super slam that subscribe button.